In this video, we'll explore what flow dynamics calibration is, why it's necessary, and how it improves print quality and extrusion control. What is flow dynamics? Filaments are not rigid bodies. They behave more like semi-fluids. When extrusion begins, the filament first compresses, which causes a delay in actual flow. So, the tool head may start moving before the filament properly catches up. Why is calibration needed? These delays can lead to underextrusion at the start or blobs at the end. To fix this, Bambu Studio applies pressure compensation, extra extrusion during speed changes. But since every filament reacts differently, calibration is needed to find the ideal value. How does it work? The printer prints test lines and measures flow response. X1 series uses micro LiDAR. A1 series uses an eddy current sensor. The result is saved directly into your filament profile. When should you run this? When switching to a new filament, after nozzle wear or replacement, if the filament is damp, when using a third-party hot end, when print temperature or max volumetric speed is changed. Limitations: if the filament is damp, flexible like TPU, or transparent, calibration results may be inaccurate. Also, if the nozzle is clogged or the bed surface isn't clean, results can be affected. Still, under normal conditions with standard filaments, this calibration is highly reliable. Conclusion: flow dynamics calibration helps ensure accurate extrusion even during rapid changes in speed or direction. This dramatically improves print quality, especially around sharp corners and fine details. Now that we understand what flow dynamics calibration is and why it's important, let's take a look at how to perform this calibration directly in Bambu Studio. Once Bambu Studio is open, we go to the top menu and click on the Calibration tab. Here, you'll see a list of different calibration options. We're going to select Flow Dynamics Calibration from this list. Before starting, make sure that the nozzle size and build plate type match your current setup on the printer. Then, select the filament you want to calibrate from your available profiles. Once everything is set, all we need to do is click the Calibrate button. The printer will automatically begin printing test lines and perform the calibration process for us. The calibration process is now complete, and we're looking at the results screen. Here, we can see the flow dynamics calibration factors for 3 different filaments. These are labeled A2, A3, and A4, and each one has a different K value. The K value tells the printer how much adjustment it needs to make to control the filament flow. A higher K value usually means the filament flows a bit slower or is harder to push, so the printer needs to compensate more. So, for stiffer or thicker flowing filaments, the K factor tends to be higher. This helps the printer handle each filament more accurately. Since each filament has unique properties, saving and tracking these values separately will make your workflow much easier. Finally, once everything is set, we click the Finish button to complete the process. In the next video, we'll move on to Flow Rate Calibration, where we check how much filament the printer is actually extruding compared to what it's supposed to.